There we go. All right. So today, and I'll share this PDF in the channel. There we go. So today we're going to talk about React a little bit more. Last week, we kind of got started with Create React App. And we can use that same exact Create React App project that we made. I had you delete all of the extraneous files that we're not going to use, like the rotating SVG of the React icon and all that fun stuff. We already got to this. So you're going to need Node.js and VS Code, which everyone already has. Create React App, which everyone's already done. Didn't really delete the source. We don't need to do this, but I think I talked about this, but just to rehash, the very top level file, the entry file of a React app looks something like this. We've got our imports at the top, and also this is going to look different when we switch to our backend projects. For now, we're using the import from syntax, but a lot of the times when you're importing stuff on the back end, because we're not using something called Babel, which lets us use the fancier, newer syntax, we have to use straight vanilla JavaScript, which we can set up Babel, but it's overkill for a server. But I mean, you're free to do it, but it takes more memory than you really need. But on the front end, it's all getting transpiled anyway, so that's why we're able to use import instead of const React DOM equals require React DOM is what the typical way to write that would be. But anyway, we're doing this for the front end. The entry function this is the entry function. Up here is a component. So this component is just a hello world, but this would be the top level component. And in our Create React app, this would be named app. I think it's named app, whatever it is. But that's the top level component. And that's what gets inserted into our HTML document. I already showed you the div with the ID of root. So React DOM render, React DOM is a concept in React that kind of makes it different from other frameworks such as Angular. React has both the real DOM that it works with and the virtual DOM. It makes changes to the virtual DOM, which doesn't actually show up on screen. Once the changes are made, that's called a render. It will do a hot swap of the real DOM and the virtual DOM. So what I mean by DOM, and it's not going to show up on this page. On this page, the DOM is the document object model. And that's what this is. This is literally just a representation in, this is kind of HTML, but not really. But this is a representation of what shows up on the page. And React has the virtual DOM, which is separate, which wouldn't show up here, where it makes all the changes that it needs to make because it's more efficient. Because when you change something in the actual DOM, it'll immediately reflect on the page. It's going to draw it on the page right away, and that can be expensive. So what React does is it creates its virtual DOM, it hot swaps it all at once, so it only draws to the page one time. And that is a memory saver. Whereas Angular, you're manipulating the DOM directly. This is an abstract concept as far as React goes. I mean, it's abstracted from you. So you don't necessarily need to know that the React DOM is a thing that exists, but it is, something that's good to know. But anyway, you're telling it to render, you're giving it the, okay, I guess this is just a image document, but you're giving it the top level component that's going to render to root. That's what's happening here. And then from there, any imports you make for any other components inside of the div, you don't have to worry about doing this. You only have to do this once. And this is talking about, so yeah, this is the DOM. You can go ahead and read the definitions. I'm going to post this PDF, like I said, at the end of the class, and I'll be sure to actually get the videos up this time to YouTube and send the links. I'm going to do that right after this, so I don't forget again. So JSX, JSX is anything that's in a couple of parentheses. It doesn't always need parentheses if it's a one-liner, but parentheses is how you denote JSX code. So this is a blend of JavaScript and HTML, and yeah, so you can write 100% vanilla HTML in JSX and it would work, but you're not taking advantage of what JSX has to offer. For instance, you can do inline JavaScript functions to dynamically render this. So in Hello World, I could have a couple of brackets, and I'll show you this live in a minute, but you could have a couple of brackets with a line of JavaScript that returns something, and whatever it returns, it'll end up in line with the code. Versus when you're working with vanilla HTML and JavaScript, you have to do get element by ID dot set, or rather get element by ID dot set. It's been so long since I've done this. Set inner HTML, or maybe it's just dot inner HTML equals whatever. You don't have to worry about that stuff. You can do all in line. So that's pretty neat. Create elements. We're not going to talk about create elements. There's a lot of stuff that's in this document that we're actually just going to go ahead and skip because it's an older way to do it and it's not going to be supported for much longer. So like create element is kind of what's happening under the hood. But it is important to know this is there for one reason that I can think of, and one only. So let's go to the code. And I'm actually, I'm going to show you something real quick. So I've got my first app inside of week 2, which is right next to week 1. So it's showing more than I really need to see. So I can go to my console and I can go, and some Zoom stuff is in my way here. CD week 1, CD my first app, wrong week, CD week 2, my first app. I'm gonna close this file or this code instance here and run code again, so that I am only seeing the folders that I need to see for my first app. So that's how you can do that. There's a new concept called a mono repo where that would actually be required for you to do. Pretty sweet. And we'll probably talk about mono repo when we start talking about the server side stuff. But for now, don't worry about that. But create element is what happens under the hood when we are using these two parentheses. When it's transpiled, React has this function that will do everything we need for us. There's component, there's props, and there's children. So component, that's the component itself that is in the parentheses. So this whole thing is the component. Children or props, we didn't talk about properties yet, but you can give properties to the app. I don't like the way this is written. I'll change this in a minute, but you can give certain properties to app, and those would actually be parameters, but in React, they're called properties or props. And that would be, like input parameters for whatever kind of custom stuff you want in here. Maybe I want to replace the word words hello world with something else, but I want it to be nice and dynamic so I can reuse this component. I would use a prop to make that happen. And then the last thing is children. You see this spread operator here. That means that there can be any number of children. Anything that follows props, child 1, comma, child 2, comma, child 3, an indeterminate number of children can be given. So in this case, this kind of is a child, I suppose, but this is a child component, just this text. Anything that fits in between these two div tags is going to be a child of div. And every React component will have a children property by default. Whether you reference it to it or not, doesn't matter, it's still there. And you can use that to compose or create like a wrapper component around other components. And that'll become useful when we're talking about like custom header components. Maybe you want all of your components to have like a header at the top for a mobile app, which I closed now, but at work here at Asurion, I work on a mobile app, and almost every component has a header wrapper is what it's called. And it just puts a little header at the top of the screen. In fact, I actually have a screenshot because I was asking my team something. This is what I'm talking about, this header. And then anything that's given to it, which is underneath it, is all the children. And what that accomplishes, it's not really needed, but what that accomplishes is styling for the most part. But anyway, that's what children are. And there's only one component here. So you can only do one component inside of parentheses. And what I mean by that is there can only be one root level component. If I try to put in a second div here, it's yelling at me right now. And if I hover my mouse over this, it'll say JSX expressions must have one parent element. So I'm trying to stuff two components into this parameter, which it doesn't like. And when I try to run this, it's going to bug out. It doesn't know how to handle it. So there can only ever be one top level component. But the way you can get around this, if for some reason you don't want a whole div wrapping both of these two divs here, you can use I forgot what it's called, but you can use a pair of empty brackets and it auto-filled for me. And this is, all right, the name's escaping me. It's in here somewhere. It's about keeping the DOM clean anyway. So these are like disappearing divs essentially. So I can wrap both of these divs inside this empty pair of brackets. This is where we're getting outside of vanilla HTML. This is fine. It converts anything between it. There's no styling. This isn't a div. When it shows up in the DOM, we're going to see that it just shows these two divs. There's nothing here. This disappears. So this is essentially a disappearing div. And when I remember the name of it, it's probably after the class, I'll post it in the Slack. But and I'll show you what that actually looks like in the DOM in a moment. Let's see. All right, so I'm actually going to rewrite this because I don't like the function syntax. If you like this better, by all means, there's really no difference other than syntactic difference. When it transpiles, it's probably going to end up like this anyway, but just because it's my preference, const app equals that. So that's how you're going to see me write everything. You don't have to. So the imports, you can import any file into this, and Webpack already has the innate ability in this Create React app to read CSS. You can pull in SVGs. You can pull in almost any type of file, and Webpack will be able to read it. And just by importing this app.css, it's already applying that CSS to everything in this page. You can also import other components, such as what we're doing in index.js. We are importing app from app. Notice that there is no file extension. Although you can put the file extension and it would work, I prefer to not have it because there's something called TypeScript, which we may or may not talk about. And if we're using TypeScript, React will be smart enough to reference either the TypeScript version or the compiled JavaScript version. So for now, we're not using, and by for now, I mean permanently, we're not using file extensions for JavaScript. But for any other file, yeah, you're going to want that. And I'll talk about the imports as well. So React and React DOM are something that we have as dependencies. So React DOM, we got React scripts, which we're not importing this anywhere. This is just for these scripts. Web Vitals, we can get rid of this. We're not using it. Testing library, we're not using it for now, but we'll talk about that later. But anytime you have a import that you want to use, we're going to be importing some other stuff like Lodash, Super Agent, other code that other people have written that they've posted to NPM for everyone to use for free, by the way, and you want to reference it, you just import it from and its name. It's not in a file structure. It does live in node modules. If I dig in here, and I'm not going to, I'm going to find a folder that says React and a folder that says React DOM. That's going to live in node modules. And by not giving it an explicit file path, it's going to be smart enough to know that that's where it can find. In fact, my mouse is hovered over it right now, it knows it's a module, and there's the file path for where it can be found. And then, yeah, files, it's going to be a relative path. So relative means relative to the file that's importing it. In this case, this app component is in the same folder as index.js. So I just use a dot, which denotes the same folder, a slash, and the name of the file. And I'm not entirely clear what strict mode does. I've never run into any differences, but that's something that I will check back with you in the documentation and let you know of. But this is probably JavaScript strict mode. Excuse me. This is probably JavaScript strict mode is probably what this is telling it to do. But again, I've seen no difference. You can go ahead and get rid of this. So yeah, so now we're just rendering the actual app component. So let's, I'm going to create a subcomponent because app is pretty much good as is, in my opinion. We're going to start looking at the file structure of React. And I've got this page open right here where I showed you the DOM. So file structure. React doesn't really explicitly tell you what the file structure should be. They basically give you a example of what it should be. Grouping by file type, you can do that as well. And yeah, the main thing, don't overthink it. Avoid too much nesting is something I definitely want to talk about because I've been on a couple of projects where the file structure is kind of complicated. There's a components folder, and inside of that folder, there's a folder for a I don't know, like table, like I don't know, customer table, and inside of that folder is all the components. And then it can get weird pretty quickly and make it harder actually to find anything. So you want to avoid too much nesting. I personally try not to go more than 3 files deep to find any file inside of the source folder. So what I typically do, and you may have a system that you probably want to work with more, I have one folder for common. So common, also utils, doesn't really matter all that much as long as you know what it's for. But this is where I store just JavaScript files with functions that I may use more frequently that I want to reuse throughout the app. So an example might be taking a number and turning it into a currency string. So I want to take 100 and I want to turn it into $100.00, something like that. And that may show up throughout the app in a bunch of places. So I would make a common file for that where multiple components can draw from. Another example could be, well, I honestly mostly use it for formatting, but stuff like that. Anything that you think will be reused throughout the app that you don't want to write more than once would go in the common/utils folder. Another folder I like to make is components. Components are going to be just dumb components. They're components that take in props. They don't have any JavaScript code really that runs in between the opening bracket and the return statement. There's no formatting that they do. There's no dynamic anything that they do really for the most part. They're just stupid components that just show what I tell it to show. And then there is controllers. Controllers are the things that will actually dictate what kind of information flows to the components. So a controller, and this will make more sense once we do it, but a controller will typically house the state, and we'll talk about state in a little bit, but it'll house state, it'll do network calls, if applicable, it'll do all that sort of stuff, and then pass that information to the components. So essentially, a component is what shows up on screen. A controller is all the stuff that happens kind of behind the scenes. There's still Java or JSX files, and they'll still ultimately spit out a component, but it's not doing any of the actual rendering. It's not doing the rendering. It'll reference the component. That's the only rendering it does. So that's generally what I do. And when I want to find a certain file, like even if my project root is something crazy, like hundreds of components, first of all, at that point, I may want to talk about splitting into a separate project. But if I have like 100 components, VS Code will sort anything in alphabetic order. So we got app.jsx up here, indexes down here. It'll sort everything alphabetically. So that's one way to find stuff. Another way to find stuff is on a Mac, it's going to be Command P, P as in Papa. On a Windows, it's going to be Control P, I think. But I could just type in the name of the file, index.js, and it'll open it right up for me. So I'm using VS Code to kind of keep my file structure nice and shallow, because if it's too deeply nested, it's actually going to be harder to find stuff, especially as the project grows. So that's my spiel on that. I'll post a link to this because there's more than, there's more than a couple of proper ways to, there's more than just a handful of ways to organize everything. There could be grouping by file type. So you got API. API would be the files that communicate. Oh, you know what? That's one thing I forgot. I do typically have an API folder. And this folder will house all the code that will actually do the comms with the internet, with my server side, once we spin one of those up. Yeah. And components, same thing. So this person's got like CSS and his JS like intermixed in here, which is fine. And typically, that's another thing. If you have a CSS specific to a certain component, some people like to break them out. Some people like to use inline styling. It really depends on how much styling there is and how reusable your CSS turns out to be. So you would want to name it the same, avatar.css, avatar.js. And in the file structure that I like to use, I would have, avatar controller, and that's the name of the actual file. It's already inside controllers, but naming it controller allows me to do this thing more easily. So I could just type in, avatar controller. And in here, I would have avatar component or simply avatar. As long as I know that, if it says controller in the name, or rather if it doesn't say anything in the name, then it's probably a component. So that's typically what I do. And anything that's in common in API, their file extensions are going to be JavaScript because they're not going to spit out components. Anything that returns a component should be named JSX. And again, I could just as easily name everything .js. I could even name index.js here. Well, this is returning a component. I don't have any other JavaScript files in here, but I can just as easily name a file that doesn't dispense any JSX at all. I can name that JSX. React does not care. That's one of the things I think made it successful because they're not opinionated. Because that, forcing a certain pattern, if it's a bad pattern, that can, kill a otherwise great framework. So React did a good thing there, I think. But that puts a little bit more discipline needed on us. We have to make sure we name our stuff according to a pattern and make sure, we're keeping up with our file structure. Are there any questions on that? Let me open the chat. Fragment. Okay. Yeah. Thank you, C4. You said this 10 minutes ago, but fragment, that was the empty brackets that I showed you. That's called a React fragment. Yeah, and Andy, you said that too. Thank you. I wasn't looking at the chat. All right, so C4, can you elaborate on your question? Because I'm out of context on it. They've implemented that in NPM. I thought it was just a Yarn feature. What was that? Monorepo? Yeah, NPM has support for monorepo, but it's not nearly as powerful as Yarn. And for those who don't know, Yarn is, so NPM is the node package manager. Yarn is also a node package manager. It does exactly the same thing as NPM, except it is, well, not quite anymore, but when it came out, it was a little bit more secure. And it has innate support for mono repos. That in line with, what is it called? Lerna, Lerna. Lerna is another monorepo style thing that you can use, and that would tell it to run a certain script in all of the folders is primarily what Lerna is for. Again, we'll talk about monorepos. I don't know if we're going to have a lot of time to dedicate to them, but that is something I want to talk about. So now what do I want to start with? So we're going to create a brand new component inside of the components folder that app will call upon and show on screen. So this new component, we could just call my component. So that's something I think I forgot to mention. Anything that's a component or a controller will be capital. And when we create the function that dispenses it, we notice that app, we notice that app is a capital A instead of a lowercase a, so that when we reference it in app.js, it'll be a capital A. Capital A, or capitals, not just A, but capital letter component names will always denote, or should rather, it's optional. It doesn't enforce it, but you should make them capitalized to distinguish them from vanilla HTML components, which will always be lowercase. And whenever I say vanilla HTML, I of course mean, you know, your divs and your paragraphs and all that fun stuff. When we get into our component libraries, I want to use Material UI. There's also Bootstrap, Bootstrap React that has a bunch of custom components. I think I showed you this last time with a bunch of, you know, fancy looking buttons and tables and all that stuff that already look nice out of the box. Those will all be capitalized as well. So my component, it's going to be a capital letter. Some versions of React, I believe they stopped making this a requirement because my IDE has stopped yelling at me for not doing this because I frequently forget, but you typically want to import React as the first thing in any React file that dispenses JSX. And yeah, declared and never used. I'm not sure that you need to do this anymore. The new version of React may have done away with it, but I'm only guessing. But anyway, const my components. And we're just going to return for now a couple of divs. Hello. So yeah, base component, it just returns this JSX, nothing fancy here. And we're going to export it. Export default my component. So export default, there's two ways to export files, or rather functions. And I like to use default because I don't have to use destructuring. But I'll show you both ways real quick. So we're going to import this into JSX or into app.jsx. So import my component. And it'll autofill for me, which is nice. Of course, it also does that. I don't like that, but. Oh yeah, semicolons. I think someone asked about this already, but semicolons are not required in JavaScript. I prefer to not have them. And it already autofilled it for me, but it's in the components folder, my component. And now I'm going to reference it as a child. And because it has no props and it has no children, I can use a self-closing tag here. My component should be set. I'll go ahead and start the app. npm start. So we can see the word hello on screen. And then we're going to start giving it props. So we can see how props work, how the children prop works, all that fun stuff. And right now Webpack is just transpiling all of our stuff and spinning up a nice server on port 3001, I think. But the good news is it has hot reloading. So as soon as I make a change in the code, it should immediately reflect on the page without having to go through this exercise every time I make a change to see what it looks like. All right, port 3000. There we go. All right, so now I see hello. Okay, interesting. So I just got a direct message. C4 attempted to install Material UI and it's not compatible with 18. So forced installing, if it's giving you an explicit warning that it's not going to work with 18, then it's not a good idea to force install. You can force install it by using -- force at the end of npm install, Material UI, but it's not a good idea. And yeah, Gracie, I'll show this. So whenever you have a question, so I see 2 people just DM'd me. If you can send it to the group so they can see your questions as well, that'd be great. So Gracie, what do you mean by opening the page?
Like how to open the website again?
Oh, okay. Yeah, so it doesn't show here, but in package.json, we have a script for start. So you're going to go to the command line and run npm start. And that should start up the server. So to C4's point, right now we're working with React 18, and we can just as easily, if we want to use Material UI, Bootstrap React may be compatible with 18. I guess I don't know that yet. 18 was just released, but we can literally just bump the version down to 17, run an npmi, and we'll have React 17 on board, and then we can install Material UI. But I kind of want to play with React Bootstrap this time around, so it may be compatible with 18. It more than likely isn't if Material UI isn't, so that's kind of annoying, but I'll find the last stable version of 17 and we'll use that just in case 18 has like security patches and stuff that we're going to want. But for now, we're not worrying about that. But we see that hello is on screen. Great. So now we can mess around with my component, maybe give it some props and make it a little bit more customizable. And that will be useful for if we have a component for, I have a app that is running on my other network, so I can't show you, but it has, it's a stock trading app, and it's got these little paper components from Material UI that show, what the ticker is, how much money I've lost, and what type of options are on it, all that fun stuff. And there's a bunch of them. So it would be, that component has a couple of different props like ticker and other stuff to make it customizable depending on what kind of information I show. So for props, let's go ahead and let's just throw text in there. So text. Oh, and I forgot one thing. So this isn't exactly like input parameters. It kind of is, but props are actually a specific parameter, props. So props is going to have all of the props that we give it, and we want to destructure it so we can reference each prop individually, although we could just leave it like this as well. So if we console log props after we give it some, and any console logs that, and I have a mobile view because I have a mobile app at work, but the console is going to be the web consoles where this is going to spit out. So the way I just got there is right click, anywhere on the page, inspect. It's going to show that virtual DOM, or not the virtual, the actual DOM. Click console, and we're going to see everything that it's that console log will spit out. So object, prototype, this is an empty object right now. But that's what I just console logged, and it'll tell me what line I consoled on as well. So my component JSX line 5. And I'll just do this to make that easier to spot. So we're not giving any props yet, so it's an empty object at the moment. So let's go back to app.jsx and props. In fact, right here, this is how you give it a prop. So in my component, and I'll make this a multi-line thing here like this, I can do text equals hello to. And we don't have it attached to anything, but we are now feeding it that prop. We can now see that it's in there. Props is an object. The key is text and the value is hello to. And props are, this will take some getting used to, but if it's just a string, then all you need is a couple of quotes, and it doesn't matter what kind of quotes you use. You could use double or single. I prefer single just because I don't have to hold down shift when I type it. If you're giving it a number, then you have to use inline JavaScript syntax. So some number equals, and I can't just give it a 2 because it's going to actually expect, it should be either an expression or quoted JSX text. So an expression means JavaScript code that'll execute and return whatever. In this case, for whatever reason, number literals, they don't like those without brackets. So this bracket, I could run a JavaScript function inside here that will return something. And whatever that return value is, that's what's going to be stored in props. In this case, simply running 2 is going to return 2, and that's what will end up in our props object. So let's look at our object again. We have some number 2. So that'll take a little getting used to. You can also just wrap everything in a couple of brackets to make that easier, because it'll work the same way with text until you figure that out. See, we got the same exact object here, but that's just something to keep in mind. And if we want it to be a Boolean, we can, because you're probably going to use a lot of Booleans as props too. So if I just type some bool, but I don't assign any value, it's implicitly going to be set to true. See that? So that's some bool is now true just because the prop is present. But if I want to set it to false, then I explicitly set it to false. Boom. And I think that's about it. And yeah, like I said, you can also invoke functions inside of there. So I can create a function in here that just returns, more text to show you this, but const some function equals blah, blah, blah. And I'll have it return gibberish. And I can invoke the function inside of these brackets. And this will be useful for, it'll be useful. But yeah, we see that our gibberish showed up in some bool here. So that's how props work. Now let's employ the props. And I'll just leave some bool as is and get rid of this function. But we have text, some number 2, and some bool. So in components, we can reference props like this if we want, but I prefer to use destructuring. So destructuring is I'm taking the props object, I'm breaking it apart by using a couple of brackets, and I'm putting the names of the props in here. So I already forgot what they were. Text, some number, and some bool. Text, some number, and some bool. And props is no longer there. That's why that's yelling at me. But now we're directly referencing the props by breaking them out using destructuring. That's the pattern that most people use. I don't really see a lot of people just use straight props and then do props.text and props.number, because it's not as easy to see what props that this component may use. In a small component like this, where we're not even using the props yet, it's probably fine. But in larger components, such as, like a whole table, it's going to be hard to know which specific props this component expects. So that's why we're doing that while we're using destructuring here. Excuse me. So I'll just put some text, or rather text, in here. Now, when we're referencing one of these props and we're doing it directly inside of JSX, we need to use those brackets because these variables, just referencing them, are technically expressions. So any JavaScript expression needs to be wrapped with a couple of brackets. If I don't do that and I just use text, then that's literally what's going to appear on screen. That doesn't do me any good. But if I want to use the variable, I wrap it in the brackets and now we have the value. So is anybody confused on that? I'm assuming that's a no. Now for dynamically showing or hiding certain components, there is, do I want to do that yet? Yeah, let's do that. So maybe I want certain pieces of this component to show or not show depending on, the value of the props. So some bool, let's change that to visible. Visible. And when I make changes to these, it's not going to yell at me if these are different than these. So you got to be careful about that. That's a problem that TypeScript would solve. And again, we'll probably talk about TypeScript a little bit later, but for now, we're just using regular old JavaScript here with React. But yeah, just, whenever you change or add a key, and maybe it's required, you got to be careful about that. Because if I just have visible without the E in the end, nothing's going to yell at me. You can pass whatever props you want. If the component doesn't use them, it doesn't use them. But yeah, this isn't going to highlight. It's not going to warn you. So just something to keep in mind. But maybe I don't want to show the text or I do. And if I want to just do this on the actual text component, I can use visible and text. So if visible is true, this is called overloading or short circuiting, by the way. If visible is false, it won't run the rest of this line and ultimately dispense text. If visible is true, then this side of the circuit will be true. It'll then invoke this side and return the value of it. This is called short circuiting. And I think it's official now, but it is kind of hacky. But if visible is false, then this won't show. So if I set this to false, it's gone. Doesn't show. And also I can go ahead and get rid of this because if I want visible to explicitly be false, or if I want visible to be false, I don't have to explicitly add it and set it to false. I can just delete it. It'll be undefined, I think. I'm pretty sure it comes up undefined, but that's as good as false. This is a falsy value. So the fact that it's falsy, it's going through this circuit. It is basically returning false on this side of the circuit and it won't show text. So yeah, so I'm going to add it back in, bring this back. All right. Now the last prop is children, and this is something that's already, it's a default part of most components. And the way you pass in children, you don't actually use a prop. You use HTML wrapping. So I want to add the concept of a child in here. So children, and then down here, I would just reference children. And the value of this prop would be React components. Although children can really be anything, I could set children to, hello 3 if I wanted, and it would show up. That is a valid React component that would show up. But the way you really use children is wrapping. So like I said, this div component here is the parent component of my component. Okay, so question, what happens if you override the children object in the actual props? So that's essentially what we're doing. We're overriding children. Well, we're not really overriding it. We're using the feature. There's not really a way to override it per se, because children can really be any value. It could be a number, it can be text, or it could be React components like what we're about to do. So So yeah, my component is already a child of div. And div is a vanilla HTML component, but if it were a legit React component, this is what it would be doing. So we're going to give my component a child. So it won't be a self-closing tag anymore. Anything that's in here will be set to children. So what am I going to put here? I don't know. I'm going to put a green box or something. So a div self-closing tag style, and this is getting into inline styling as well. So inline styling is what I'm about to put in here is kind of CSS, but not really. CSS is usually snake case, whereas in inline style with React, it's camel case. And camel case is lowercase to start with and uppercase like this. Hang on, I'll just do this. This is snake case. This is camel case. So most CSS is snake case like this, but when we're using inline styling, it is camel case. So anyway, width, I don't know, 100 px, heights, 100 px, and background green. There we go. So this is rendering because of this children prop that we are giving it. And it always sets it to children. And oh, you know what? C4, I think I understood what you meant by that. If we actually set children as a prop, I'm not sure what takes precedence actually. I think the actual children will take precedence. So if I set this to something, then it's going to ignore it and use what the actual children are. But if I were to get rid of this, and what I just did, I on a Mac command / on a Windows control /, and that'll automatically comment out in the style that it wants. Because regular comments like you might be used to, it won't work here. Anyway, so yeah, 3. So it doesn't override when you set it as an actual prop. You should never do this really. You should always use a wrapping, HTML wrapping like this for children. But yeah, if it has actual children, then it's going to ignore whatever you set as prop up here. So C4, that's what you were asking, right? Cool. But yeah, that's children. So this will be useful for, there's something called composition. And composition is, it's hard to explain without actually doing it, but I could have, app.jsx reference my component, which might reference smaller components, and those themselves might reference components and so on. And they're all children of each other. And you're going like 8 files deep, potentially. That is generally considered bad practice. So composition would be, if I have, all those nested components that end up being, children of components, you can use the children prop here to do composition. So composition meaning this green box that I made is actually created inside of app.jsx. My component has no idea what children's going to be, and it doesn't care. And this is a way to, when we start working with state, state would be stuff like, a user types something into a text box. The value of that text box is in state somewhere. It's going to be referenced elsewhere. That's called state. And, whether a component is, like a checkbox, if it's marked or not, or data coming from the API, it would save that to state. That's, whatever variables that you're working with in your program. That may change and hence our variable. You want to use composition because, let's say app has some state up here. So const my state equals something. And ultimately this state will make it into like a, 6 child deep component of my component. I can either pass that as props down every single component, every parent passing it to its child and so on until it gets where it needs to go. Or you can use composition, and this div, for instance, can be given that state directly at the top level component. This is called composition, and this is good practice in general, and it'll make your app a lot more maintainable. But that's what I mean by that. The alternative is what I just described with passing my state down, down each child component until it gets where it needs to go. That's called prop drilling, and it can become a massive pain. Prop drilling sucks. So if you find yourself having to make these components with the same exact prop over and over again, then you're doing something wrong. But as our apps get a little bit more complex, then we'll talk more about composition. So I'm just going to get rid of this. And I'll get rid of my state because we're not talking about state yet. But yeah, does anybody have any questions on how children works, how props in general work, anything? Everyone understands this perfectly? Good. If you have any questions, stop me anytime. So what else do I want to go over? So we talked about props. There's JSX nesting, which is, that's composition essentially. Yeah. So I wanted to show you the DOM thing with React Fragment. So right now our DOM is, pretty clean. There's not a lot going on here. We've got some nested div here that we may not want, but that's kind of fine. But generally speaking, you want as few divs and spans and whatever as needed in order to achieve the same effect. So Fragment can help with that. Because if this DOM gets a little too, they say the DOM is dirty when there's just a bunch of divs that really don't need to be there, then it can cause performance issues, particularly on mobile phones, because a lot of apps are made to work on both desktop and mobile, right? So you want to keep the DOM as clean as practical. So if you've got a div that's just by itself, there's no reason for it to be a div at all, because div, what do I want to say? When you position two divs next to each other, they're actually going to be, they're not going to be in line. They're going to be up and down, and spans are going to be side to side. But that's some CSS magic that you can play with to force them next to each other. But we're not getting into that right now. But if the only reason you have a div is just to contain something, then you'd want to use a fragment instead. So I'm going to get rid of all of this actually for now. And I want two divs next to each other. So because I'm giving it two upper level components here, or parent elements, it's yelling at me. So a lot of times people will just create a div like this. Hang on, let me make this look a little less. There we go. So this div, its only purpose is to contain these two elements here, these two other divs. And in the DOM, we can see hello and goodbye here right next to each other in this containing div. And if we don't want to, or rather, if we want to keep our DOM clean, then we would use the fragment. So when I use the fragment instead of this div's just going to disappear, and we're going to have these two divs left, and they're going to look exactly the same. So this is what I'm saying. Where practical, you want to use fragments instead of divs. See, that looks exactly the same, but now that parent level div that was in here is no longer there. All we have are these two divs. So that's where you would want to use a fragment. So try to make liberal use of fragments wherever you can, because when it's transpiled, it'll make a performance difference in a larger app. And this one, it doesn't really matter. because there's only like, 4 of them to begin with. But in larger apps such as Facebook, they, I'm sure, use liberal use of fragments because Facebook, there's a lot to it, right? There's hundreds of different components and some of them are right next to each other. And it doesn't make sense to contain all of them inside divs. If all of the fragments that I bet they use were divs instead, or even spans, then Facebook would be a much slower app. So that's that. Let's see what else. Kind of went over this. So this is talking about parent and children components and the fragments. So adding JavaScript. So we talked a little bit about this, but we'll go a little bit deeper. We're going to bring my component back. And my component, we're just going to go ahead and have this at the top level. We don't need the fragments here because it's just my component that's showing. But I'm going to keep them there because we might want to make new components. And we're going to get rid of the props for now. Actually, no, we're going to keep the props, but we're going to get rid of children and we're going to get rid of visible. We're just going to have text. So this will be a very basic component. And why isn't it showing? Because I don't have text set here. All right. So I'm going to keep this nice and simple, but this is how we can use JavaScript in line with our JSX. And we may want to, you know what, I'm going to jump into map. So we went over map and reduce and filter and all that stuff specifically before we jumped into this for a reason. So most of the time you're going to have lists or arrays rather of objects that you want to show on screen. And it may be an indeterminate amount of them, such as, maybe a table that has a bunch of customers and each row is another React component. We're not going to work with tables yet, but that's an indeterminate amount of them. There could be 0, there could be 1,005. We have no idea. So we have to use the map function to create a list of React components that'll eventually show on screen. So my components, that's going to be our component that we're going to make a bunch of for each individual item in a list. So let's create that customers, or rather that employees array again, and we'll just do that from scratch. So employees equals, and I'm gonna just have this as a list of strings for now. So Mike, Isha, George, Matt, and we'll leave it at that. So we have our list of employees. Maybe this came, or yeah, this probably came from a server. It's not going to be hard coded, but we want to show one my component for each of our employees, and we want their names to show up on the screen. So we're going to use the map function, and we can do this inline, or we can create a function on the outside of this return statement. Either works. My rule of thumb is if it's more than a couple of lines, like by a couple, I mean more than 3 lines, then I'm going to want it outside of the return statement, but we'll do it in line for now. So because we're using a JavaScript statement, we need these brackets. And if you press enter, it should do this automatically for you. But format the brackets like this. And we're going to do employees.map, employee. And for each employee, we're going to return a little bit of JSX code. And right now it's yelling at me because it's empty. My components, text equals, an employee is literally just a string. So I could put employee and closing tag. So this will return a list of my components, and each one will have the name of that employee. So this is why we went over map. Map is going to be used pretty much extensively throughout React. It's built to be used for it. Try doing this in a for loop. You're not, well, you can, but it's going to look terrible. And you certainly couldn't do it in line. One stipulation that I may have mentioned is when you have these brackets, it's got to be a one-liner essentially. a function such as, dot map, or yeah, it's got to be a one-liner, because if I try to write additional code down here, it's going to fail. So let's just do a simple console log hello. Don't like that. It's got to be a single statement. So that's why map is used, because if you try to do this in a for loop, and I'll just comment this out, for let x equals 0, x is less than employees dot length, x plus plus. Yeah, it's already not liking this. It doesn't like for loops inside of here. It's technically not an expression. That's the word I was looking for, not statement. But it is an expression, but it's hard to explain. It just doesn't like for loops in line. If you really like for loops for whatever reason, then you can do a for loop outside of here to create a list of components. But generally, you want to use map. And you can also chain them. That's something that I forgot to go over. So you can chain higher order functions after each other. So if I only want employees whose name starts with an M or something, then I can do a dot filter prior to the map. X dot includes M. This isn't start with name, but it's close enough. It'll filter out the employees first and then map over them. I think I forgot to go over this when we were doing our JavaScript refresher, but you can chain them, which you may end up using as well. So that's how to make that list of components. And again, if these were objects, then I would just reference employee.name inside of these brackets here, and it would achieve the same effect. So I'm going to get rid of this filter. And because this is only a few lines, or yeah, just a few lines long, and in fact, I can make it shorter. I can get rid of this return. I can get rid of the bracket and make this one line. And technically, because this is also a one-liner, it's a self-closing bracket, it's not a multi-line thing, I can even get rid of the parentheses here to make this a little cleaner. You can't always do this. You can only do it when it's a one-liner like this. If it's a nested component that's got children and such, then you won't be able to do this. But this, makes that nice and concise. I know I'm making a my component for every employee here. But yeah, that's how you do that. I went through the material for today a little quicker than I planned, but we got about a little less than 15 minutes left. Is there anything you want me to go over? Maybe something you're still confused about? Any questions? Nope. All right. So I'll post this PDF in the channel. We're going to start talking about, let's go into conditionals. Why not? So I already talked about one conditional, and that's the short circuiting. That's with the and for visible. Now, how do I show this? Let's see. So you can do inline conditionals. So if I set, and I'm not going to make a prop for app. I'm just going to write an actual variable here, but const visible equals true. So visible, whether it's visible or not, I do this every time. So this is short circuiting. This is one of the conditionals. Another conditional would be a ternary statement. So if I have a variable that's, true or false, or one value or another, and that influenced what shows on the page, then I would want to use a ternary statement. So a ternary would be, variable equals condition question if true, if false. So a ternary is essentially the same as a chain of if statements, except except it only has two possibilities. Generally, you can use nested ternaries, but it looks disgusting, so don't do it. But a ternary starts with a condition. And I guess in this case, a condition would be visible. And I can do visible equals true, or I could just have visible because true itself is a truthy. And otherwise, if it's a falsy, but if visible is true, it'll return whatever value is here if true. And if it's false, it'll return if false. So that's the basic outline of a ternary statement. So, and it sets it whatever the result of this variable. So in this case, the whatever is in if true would show up in this variable here. So I'm going to get rid of this. So visible question, you can see me, or you can't see me. So because it's true, it'll return you can see me inside of this conditional. And this could be anything. Again, it could be a string, it could be a number, it could be a React component, whatever you want it to be. And when I set this to false, it'll show you can't see me. So any questions on ternaries? This will come up quite a bit, I think. And you may want to do this in line, maybe you don't. Some people find this a little harder to read, especially when I've got multi-line React components in here, because this can become a little weird, and the formatting with this is a little weird as well. This is just a one-liner, so it's not that bad. But if I've got full React components in here, then I would want to, press enter on these two brackets, and then I want these to be on their own separate lines. And you can see how this can get messy pretty quickly. So some people opt to just use like a function with an if statement. So const visible components. And if you've got more than two different possibilities, you may want to use a function instead. But visible components, if visible, return you can see me, else return you can't see me. So in this case, a ternary would be better because we've got these two if statements. We've got a whole function to call it, and visible is probably going to be out of scope when I do this, but let's just see what happens. Okay, because it's being called down here, it has access to visible, even though it's declared up here. So it's a little weird, but if you've got multiple different possibilities, if, not visible and some other condition, else if, and then, if you've got more than two conditions, then you'll just want to make a component like this. And you want to make a component instead of just having if else statements inside of, yeah, this is yelling at me. But you can do a let value equals something and then do if statements to change this value, but a function returning it would be better, just because in my mind anyway, and Richa may disagree, and a lot of other people will disagree. This is just my personal preference, but I don't like to mutate variables ever. I don't like to use the let keyword ever if I can help it. So I want to make a function that'll actually return whatever the value is. Because if I have, if visible value equals you can see me, invisible is out down here. So let's move it. But this, this is simple enough, but if you do this too much, then you can run into bugs that are hard to find because your variables are mutated. Whereas if you have a function that returns a thing, then you can test that function directly with whatever inputs you're giving it, or you can console log, new variables that you're creating along the way that you're, as you're mutating the, not mutating, but as you're changing the value, you can console log every step of the way. Whereas with this, it can be harder to track down bugs. So that's just why it's my personal preference. Again, if I see lets in your code, I'm not gonna say anything, but just throwing that out there. You probably want to make a function that returns whatever you need it to return. But yeah, we got 5 minutes left. I'm gonna go ahead and post this. There's a lot of stuff in here that I didn't go over. There's gonna be like or rather class components in here that we're not really gonna talk about. I'm gonna spend all of 30 seconds on class components when we get there, so you can see what the new style components, the functional components are doing under the hood. But don't read too far into that. But that's what we're gonna do next time. We're gonna make a class component. We're gonna start integrating state. We're gonna do it the hard way first, so you can see what's going on under the hood. And then we're going to use a functional component, and you're gonna see how much better that is. And we're gonna start using use state and other what are called React hooks, which is actually a different PDF, I think. Yeah, this talks about class components and stuff, but I'll post this. I'm gonna make sure immediately after this class, I'm gonna get the recordings up in YouTube and post links to those. And yeah, does anybody have any questions at all? Is everyone able to get this working on their end as we were coding? I'm hearing crickets, so I guess everyone's good to go. Yeah, for sure. I'm gonna stop the recording.